Hello student, let us see the problem number 47, right? So what the problem is, student, which is the wrong? Firstly, you keep in mind, student, they are asking the wrong, not the correct. Which is the wrong regarding the density of alkali metal. Okay, so down the group, student, density, density changes. Okay, density changes not in the regular manner, student. Down the group, density changes not in the regular manner. Density increases, we can write that is density increases in irregular manner. Okay, one exception is there, student. What is that? Is the most highest density, that is cgm is there, student. Okay, so down the group I am writing, that is, if in the different way I am writing, student. So density increases, I wrote density, so most one is cgm. Then which one will come, student? Cgm, then it will come rubidium. Okay, and then it is sodium, then potassium. Okay, student, and then lithium. So potassium is having lesser density than the sodium. Why, student? Because of the, here is d orbital is there, due to vacant d orbital, so vacant d orbital is there, student. So due to what? That is volume increase, student. And so denominator, because d is equal to m by v, so vacant d orbital is there, so volume is high, high for potassium. So denominator is high, so density, what happens, student? Density decreases. Okay, so density decreases, dear student, density decreases. So here if you talk about here, the which is wrong statement, here this is option number 2, potassium is greater than sodium. This is absolutely wrong, student. Potassium is less than sodium. Okay, this is what the order is all about. Down the group it is increasing. Okay, so down the group it is increasing, so cgm is highest, student. So let us try to understand, student. Means this is the wrong. Okay, option 2 is wrong. It should be k less than na, k less than na. So let us have a look over it, student. The density, these elements have low density which increases down the group from lithium to cesium due to their large size. Potassium K is lighter than sodium because potassium contain vacant D cell, and ineffective packing. What is there? Ineffective, not affecting, ineffective packing in the crystal lattice. So highest density cesium, rubidium, sodium, potassium and lithium. Let us have more explanation, student. The density of alkali metals are low and increases in different down the group. What they say, the low density is attributed due to large atomic size and weak metallic bond of alkali metal. Down the group, lithium to cesium, both atomic size and atomic mass increases, but the corresponding increases in the atomic mass is not compensated by the increase in atomic volume. Hence, the ratio of atomic mass and volume density gradually increases. So that is where see lithium 0.53, sodium 0.97. So sodium is greater than 0.86, potassium, then rubidium and cesium. So you can see, okay, sodium is the density of potassium is lower than that of either sodium or rubidium, Let us have a why the potassium is lower density. This can be explained on the basis of disproportionality. Larger metallic radius of potassium, at potassium 3d and 4s have almost the same energy, hence 4s 1 electron is free to move to 3d orbital, leading to an expansion in the size, of the atom. So potassium atom has a metallic radius much near to that of the rubidium than the sodium. Since the alkali metal all of similar crystal structure BCC, the disproportionately larger size of volume of potassium atom correspond to low density of potassium. Lithium is the lightest metal having the density of 0.534 gram per centimeter cube. It cannot be stored in kerosene oil because it floats on the surface. It kept wrapped in the paraffin wax. So what they are saying, student, because of the D subcell, potassium is having lower density than the sodium. So our required answer is option number 2. Thank you so much for watching, friends.